Today we discuss about rotational mechanics, in which we study about topic moment of inertia. By definition, moment of inertia of a particle is mr square, where m is the mass of the particle, r is the distance from the axis. Remember, all the rotational variables are axis dependent. Axis is very important in rotational mechanics. Let us take an axis and a particle. What is r? R is the perpendicular distance. Remember, r is perpendicular distance. You can't take distance from anywhere. For better clarity, this is r. R is perpendicular distance. Remember, sir, does it require the particle to rotate to have moment of inertia? No. Even particle is at rest, you can take moment of inertia. No problem. I is equal to mr square. Next thing, sir, is it a scalar? My statement is yes and no. Both are there. See, the problem is there is there are quantities scalar, vector, and one more quantity is the tensor, which is not in your syllabus, so no need to discuss. But moment of inertia is a tensor actually. Moment of inertia is a tensor. But for you, for all mathematical purpose, you can treat it as scalar. But remember, when you're adding moment of inertia of two bodies, you can't blindly add. You have to add only about same axis. Means what? You have two particles, right? Now, you can't add moment of inertia of these two particles about two different axes. Like this particle has moment of inertia about this axis. This particle has moment of inertia about this axis. You can't blindly add them. No. Right? But assume that you have two particles and moment of inertia about this axis. Sorry, moment of inertia of this particle about this axis and moment of inertia of this particle about same axis is there. Then you can add. Right? So treat it like a scalar, but remember it's a tensor. Remember it's a just tensor, okay? Right. Generally, very, very common mistake is that, sir, Ix is equal to, right? X component is this one, na? So m r square cos square theta. Pochivada. Why? See, this is not a vector quantity where you are taking x component and y component. Perfect definition is there. That is, moment of inertia about x-axis is nothing but m r square, where r is the perpendicular distance from x-axis, right? So, common mistake for the student is they take r as a vector, they take x component for moment of inertia along x-axis, y component for moment of inertia about y-axis. Along z-axis, there is no component, so moment of inertia along z-axis is 0. No, observe this. Moment of inertia crystal clear. Perpendicular distance from the axis, right? So let us write the perpendicular distances. R sin theta, R cos theta. Will you accept it? Now tell me, when I calculate moment of inertia about x-axis, Ix is equal to m is m only. You don't have any problem. What is the perpendicular distance from x-axis to the particle? Tell me.
R sin theta.
That's it. R sin theta. So r square sin square theta will come. Then what is Iy? Tell me.
mr square cos square.
mr square cos square.
Yeah, mr square cos square theta. The perpendicular distance is very important. What about Iz?
mr square.
Correct, mr square, because z-axis, I can't show it to you. Do one thing, take your pen or pencil, keep at this point and keep the pencil perpendicular to the screen. That is z-axis. For that axis, perpendicular distance is r only, na? Just observe it. Ix plus Iy is equal to Iz. So first and foremost mistake, very common it is, nothing wrong in it. Learn from your mistake. What does that tell me? Generally student will do, it's a vector quantity, x component, y component, z component, componental, it's a scalar. Clear? Question number 2, solve. We have coordinate system here. And observe, there is a particle. Okay? There is a particle. I'll try my level best to use the scale, but not to the perfection. Okay? X value is 2, y value is 1, right? Check it, x value 2, y value 1, like this. So somehow I made this some amount of scale here. Check it, this and this is there, right? But what about Z? Z you can't indicate. You can't indicate. Sir, we can indicate like this. Kana Vana, that's not correct. That's out of plane. This point, when three-dimensional comes in, student skill that he has to pick up the right axis. Do you remember? When you have an inclined plane problem like this, when you have a block or something, you can take vertical, horizontal axis also. You can solve. But the best axis is what? Tell me, for inclined plane problems? Along the incline, perpendicular incline. Okay. So, it's the ability of the student to pick up the right axis. That ability has to be there. Now, here also, you need to have that ability. You should know how to see the system. You see X, Y or something. Let us assume that you're looking through X-axis. What? Check it. You are looking through what? X-axis. When you look through X-axis, how the particle system looks, and when you look through Y-axis, how it looks, when you look through Z-axis, how it looks. So you are able to see the 3D in a perfect way. Understood? If you look through X-axis, how the particle will be and what will be the coordinates, right? First and foremost thing, when you look through X-axis, Y-axis will be like this and Z will be out of the plane, it will be like this. Are you able to feel it? If you look through X-axis, then observe particle will be here and this is R, perpendicular distance from X-axis, and this is 3 and 1. Check it, yes or no? Are you convinced? Z is 3, right? Now, what is the perpendicular distance from X-axis? Root 10, right? Because whatever X value of 2 will not generate any kind of perpendicular distance, because when you move along X-axis by 2, perpendicular distance won't increase or decrease, it is 0 only. Now, when you go along Y-axis by 1 like this, then perpendicular distance is 1. When you go along Z-axis like this, the perpendicular distance will be 1 square plus 3 square under root 10. So what is the moment of inertia about X-axis? Anyone who can tell me right now?
Only root 10.
Yeah, root 10.
10, sir, 10. 10.
10 into mass. Mass is also there, na?
1 kg.
Oh, 1 kg. So correct. Perfect. Moment of inertia Ix is equal to m r square root 10 whole square. Okay. That is equal to 10 moment of inertia. Okay. Unit is kg meter square. Kg meter square, right? That is Ix. Now, what to do? Wait. Iz is already there, na? This is Iz, right? About Z, you are looking from Z axis, right? Now, what is the perpendicular distance? Tell me. 2 square 4, 1 square 1, root 5, right? So Iz is equal to 1 into root 5 square is what? 5. 5 kg meter square. Perpendicular distance is the core idea. What else left? Along y-axis? Yes, when you look along y-axis, it will be like this, right? Sir, why? Check it. Whatever is the distance along y-axis, 1 is not of use. Isn't it? So, what is Iy? Iy is equal to, do you want me to explain y root 13? 3 square 9, 2 square 4. So, right. Iy is equal to 13 kg meter square. Kg meter square, right? Understood? What? Everything is fine. Just, I told you here, observe Ix plus Iy is equal to Iz, right? But here, Ix plus Iy is not equal to Iz. Just remember that. Don't ask me why for time being. So calculating moment of inertia is one part. Just observe, keep observing that Ix plus Iy is not equal to Iz. But here Ix plus Iy is equal to Iz, okay? Just remember that. So with these two questions, I'm reinforcing a point that remember, it's a matter of perpendicular distance, right? Don't take components like vector. Be careful. Clear? Two particle system. 2 kg, 2 kg. Oh, what to do? Nothing. You calculate moment of inertia of each particle. Treat them like scalar. Add them. Only recommendation, only thing that you need to remember is moment of inertia of both the particles or both the bodies must be calculated about same axis. That's the rule. Okay, so axis is here. You know the distance. This is 2 kg, this is also 2 kg. Total is 10. So this will be 5. Of course, the other one is also 5. This is 5 meters. The other one is also 5 meters. So moment of inertia is equal to mr square. M is 2 kg. What is R? R is equal to 5. 5 square is 25. This is the moment of inertia of one particle. We have totally 2 particles like this. Into 2. What is the value? 100 kg meter square. Three particles are there. What axis? X axis we take. We need to take particles like 1, 2, 3, something we need to. Okay. Let us take this angle is 60 degrees, because it's an equilateral triangle. I'll take this as first particle, second particle, third particle. You can take anything as first particle, second part, doesn't matter. Now, one at a time I'll take. Let us take the case of x-axis. So I'm calculating moment of inertia about x-axis, Ix. Ix is equal to. Now focus on this. This height is h. Height of an equilateral triangle. Anyone who can help me out? Root 3 by 2a. Yes or no? Height h is equal to, right? And in this case, height h itself is the perpendicular distance for this particle. So moment of inertia about x-axis is equal to m into root 3 by 2a whole square. It will be 3a square by 4 plus, that's for particle 1. What about particle 2? Particle 2 is 0. Particle 3 is also 0. Why? Because they are on the axis, right? They're on the axis. So moment of inertia about x-axis is equal to 3ma square by 4. This is the answer. Clear? Good. What about Iy? Y-axis you take. So Iy is equal to first particle mass m. What is the perpendicular distance for this first particle? Anyone? 0. It's on the axis. So m into 0 plus second particle. Second particle m into distance is a by 2 whole square plus third particle. That's also a by 2 only, na? Perpendicular distance, right? M into a by 2 whole square. So I don't write in detail. Quickly, I'll go for that. Iy is equal to, this is 0. A square by 4 plus a square by 4 is a square by 2. 2m a square by 4. Sir, a square by 2, yeah, correct. A square by 2 is also okay. This is also okay, na? You don't have any problem. Good. Then Iz. Then what? Iz. Iz is equal to, observe z-axis. How to feel the z-axis? Keep your pencil or pen, whatever is there with you, exactly at this point and keep it perpendicular screen. That is z-axis. So perpendicular distance of the first particle is this one, second particle is this one, third particle is this one, right? All three particles are perpendicular. So m into height h is root 3 by 2a square will be 3a square by 4 plus m into this perpendicular distance is a by 2. A by 2 whole square will be a square by 4 plus m into a square by 4. If you add them, Iz will be equal to, denominator of 4 is there. Simply you can add the numerator 3 plus 1 plus 1. 5m a square by 4. Now, if you observe closely, again, in the previous case, Ix plus Iy is not equal to Iz. But again, in this case, Ix plus Iy is equal to Iz. Tarun, tell me why it is valid in this case, why it is not in the previous case?
Because in the previous case, the particle had a z coordinate, but in this case, the particle doesn't have a z coordinate.
Super. He picked up the right thing. That is, in this case, in first case, it is valid because it doesn't have any z component. Second case, it is not valid because it has some z component. Third case is also valid because no particle has z component. Z component illa, you can use Ix plus Iy is equal to Z. Okay. Super logic. Actually, it's a theorem that's called as perpendicular axis theorem. Okay. We'll discuss that later. Go ahead with the next question fast. We have two particles, M1, M2, and they're separated by distance r. From r, from m1 distance is x. What value of x moment of inertia will be minimum? Yes, it depends on distance. Sir, midpoint. Why midpoint? Sir, midpoint is special, sir. But in reality, no, it's not midpoint. Now, what to do? Any boundary condition you can conclude? Sir, I don't know why. I personally feel that m1 equal to m2, then midpoint. Okay. But still, there is no proper logic for midpoint, right? But one thing you can do. If m1 is infinity, m1 is equal to infinity, then think about it. Taking moment of inertia about m1 axis is the best, na? Because although mass is infinity, if you take axis at the particle m1 itself, its moment of inertia becomes 0, right or wrong? So if m1 is equal to infinity, then I feel that x equal to 0 is the key logic. If same thing, m1 equal to 0, moment of inertia 0, that means m1L, you have only one particle, that is m2. What axis will give you minimum moment of inertia? X equal to r. Are you able to get the logical? Because when you take axis exactly at m2, m1 is already not there. If you take axis at m2, the moment of inertia becomes 0. So x must be equal to r. Are you able to understand how I'm picking up the boundary conditions? Sir, why boundary conditions? You need to understand. Sometimes if ABCD options are there, boundary condition will give answer quickly. You don't need to solve. So boundary conditions, if you can pick up, two things it will do. One is that you can eliminate the answers and you can quickly get the answer. Second thing is that if you got the answer, you can cross check it. Is it making sense or not? To decrease the error, these kind of boundary conditions, common sense, like suppose if you got angle theta is equal to sine inverse of 2. Practically sine inverse of 2 is not possible because sine value cannot be more than 1. This kind of sense has to work continuously, which will minimize your error. Error is very important because it takes off 1 mark, -1 it is. Okay. Anyway, let us continue. Now it is matter of maxima minima. Moment of inertia, I for the system will be equal to m1 x square plus m2 into r minus x whole square, right? Now, what to do? Di by dx, because moment of inertia change when x changes. If you start moving the axis slowly, what happens? X value will change, right? X value will keep on changing. So when x value changes, what happens? Moment of inertia will change. So we have to differentiate and equate it to 0 to get the maxima or minima. That is equal to, when I'm doing differentiation, m1 is a constant, it comes out. Differentiation of x square is 2x, right? Then plus m2 comes out. Differentiation of r minus x whole square. Wait. Chain rule we have to use. Okay. 2 into r minus x. We need little bit of space here, right? Good. 2 into r minus x. Differentiation of minus x will be -1, right? It's a chain rule, or else whatever method you want, you do it. Right. Now, if you solve it, you will get the answer. That is equal, that implies 2x m1 is equal to m2 into 2r minus 2x. Now, if you solve this, you will get the answer. 2 is cancelled. Good. Now solve it. That implies m2x is there. If you bring it on this side, it will be plus m2x. So x into m1 plus m2 is equal to m2r. Right? That implies x is equal to m2r by m1 plus m2. Anyone is there who can detect something, sir? This is any detection? It is center of mass. Center of mass. So moment of inertia is minimum about center of mass. I can prove this in another way also. I'll do it later. But for time being, with these two particle system, at least I can say moment of inertia is minimum about center of mass. That's why I think you might have seen this in your life. Have you seen this? What does that tell me? Railway gate. I tried my level best to get a right picture, but I'm not able to get it. Focus on this. If you saw railway gate, there will be a long pole and there will be heavy mass on the left hand side. Why that extra heavy mass? To bring the center of mass to the exactly axis. If you bring it to center of mass to the axis, then what happens? Tell me. Moment of inertia will be minimum. Yeah, it will be easy to rotate. Without that, it will be very difficult. I think you saw this also. Clock. Why this small extra piece for seconds hand? Observed it? Will be there. Why? Again, same point. Center of mass. Moment of inertia is minimum about center of mass. Suppose if you take it like this extra mass is there, na? If you take axis here, center of mass will be here. So that will do what? Tell me. That will decrease the moment of inertia. Okay. Question number 6. Let us take only x and y axis first. Then we take the x dash, y dash and all. Check it. Right. Now observe. That is first and foremost thing, ix. To do that, we need to go for number 1, 2, 3, 4. You can take anything, completely random. So moment of inertia about x-axis, that is equal to 0. Why? Because particle is on the axis. Second one, 0. Second particle also, because it's on the axis. What the perpendicular distance? 0, right? Plus, what is the third particle? What is the perpendicular distance? A, ma square, right? Then, what about fourth particle? Fourth particle is also at a perpendicular distance of A only, na? Plus ma square. Moment of inertia about x-axis must be equal to ma square, right? Now let us go for y-axis. Moment of inertia about y-axis, iy. First particle is
It is 2 ma square.
yeah,
2 ma square.
silly mistake. 2 ma square, correct. 2 ma square. And iy first particle, it's on the axis, right? So ma is 0. Plus second particle, ma square, because perpendicular distance is a. Plus third particle, ma square. Fourth particle, 0. Right? So total value, iy is equal to 2ma square. Iy is equal to 2ma square. Clear? So ix equal to iy, but I don't know whether you can pick it up or not by sense. If you don't take x and y axis, if you don't take all these things, if you look at it like, just a minute, let us remove the axis here. If I remove the axis and remove the numbers also, you can sense that, along this axis, or this axis, all these axes will have same moment of inertia, right? That there is a sense that sense, you can pick up the mass, the way the mass is distributed is same, right? By sense, you can pick up this one, right? Now let us go for the second part. What second part? We need to take the moment of inertia about what? X dash and y dash. I made it. Now again, 1, 2, 3, 4 is there. Ix dash is equal to, first particle is m. Perpendicular distance will be how much? Tell me. A by 2. A square by 4 plus, this is also a square by 4, this is also a square by 4, this is also a square by 4. Instead of writing in 4 times into 4, I'll do it. Direct answer will be ma square. Each and every particle is at a distance of what? Tell me. A by 2 only, na? Once you got it, sir, iy dash also same, right? Iy dash also ma square, because same way the mass is distributed, right? So that's the thing you need to understand. Okay. If you want, you can further continue with this question. Example, if you take an axis, which is a diagonal, I1 like this, can you calculate? So I1 also ma square. Why? Observe, you need to find the perpendicular distance, this 2. 3 and 1 doesn't matter because they're 0. So I1 is equal to 0 plus m into, what the perpendicular distance? Tell me. This is a. This is a by root 2. A by root 2 whole square. A square by 2. That's the moment of inertia, particle 2. Plus Particle 3 is 0. Particle 4 is same, ma square by 2. Sir, to particle 2 on the right hand side, particle 4 on the left hand side. So don't we use minus sign? No. Moment of inertia? No. Right. So final answer is what? Tell me. I1 is equal to ma square. Sir, I have a doubt. Ix is ma square, Iy ma square. I can understand the mass distribution is same. How come I1 is also same? How come I1 is also same? You may be having. Actually, yes. By looking into it logically, you may not be able to conclude, but it's a surprise. Even for me also, first time when I saw about any axis, in case of this square plate, not cube, for square plate, about any axis, maybe whatever angle it's making doesn't matter. Moment of inertia is ma square only, about this axis. But if you go for this axis, it will change. Question number 7 is based on integration, because particle means you can do it when it comes down to body. Now, how to deal with it? Before going to that, you need to remember density is equal to mass by volume. This is not exactly right. It is volume mass density. And sigma. What is sigma? Mass by area. Okay. And lambda. What is lambda? Mass by length. These three things you need to know. Okay. When you have a rod or a string, we use linear mass density. When you have a sheet of paper or metal plate, whatever it is, something which is planar, we use areal mass density. And when we have a volume object like cube or sphere or whatever it is, we use volume. Density is one of the things that you need to know, right? All three are mass densities only, but this is a volume mass density, areal mass density, and linear mass density. You need to know this. That's the first thing that I'm expecting. We have a rod of mass m, and we need to find moment of inertia about this axis. Okay, how to find it? The formula for moment of inertia for a body will be integration formula, will be integral r square dm. What it says is that take a very small mass dm, find perpendicular distance for that mass, and calculate r square dm will give you small moment of inertia of that small piece. Can you understand that? So right now what this is demanding, it's demanding very simple dm, take small mass, and r square dm. R is the perpendicular distance. So let us take small mass dm. I'm taking very, very small mass. And because it's so small, you can treat it as a particle. Moment of inertia particle is mr square. Instead of m, we have to use dm, right? So this has small mass dm, right? Dm, and small location of it is at perpendicular distance is r. So by calculating r square dm, you got the small amount of moment of inertia. Now by integrating, you will get total moment of inertia. Okay. And remember the small length is dr. Small length is dr you need to take. Now we have to go for that, data is there. Yeah, r square is there, dm is there, everything is perfect. This is the basic formula. Now in this question, if I take it, I is equal to integral r square d capital M. Okay, r square d capital M. Now focus on this. Now observe, you need to find link between r and dm. As it is a body which is like a rod or linear, you can say like this, link between these two, mass and length will be generally linear mass density. So what is linear mass density? Lambda is equal to total mass by total length you can take, or small mass dm by small length dr also you can take. This one. Once you have this idea, then you can make it. Dm can be converted into dr. How? Dm is equal to m by l into dr, right? Dm is equal to, you can write this one here. Sir, can't we convert r to m? 100% you can do that also, is your choice. That is equal to integral r square. What is dm? Capital M by L into dr. So capital M by L will come out because it's a constant. It comes out of integration r square dr. That is equal to capital M by L into r cube by 3. Of course, L value must be 0 to capital L. When you are integrating, you have to integrate between the limits, right? It starts from 0, goes to the, until the end means L, na? Right. So if you apply limits, it will be M by L into L cube by 3 minus 0. I don't write all these things. So if you simplify this, it will be moment of inertia about the end will be ml square by 3. If you want to calculate moment of inertia about center of mass or the center, Very simple. Integration is same. Everything is same. Only difference is you start at minus L by 2 to plus L by 2. You carry on with it. That moment of inertia will be ml square by 12. You have to do it. I repeat. Everything will be same. Only boundaries will change. I need to integrate from minus L by 2 to plus L by 2. Understood? Minus L by 2 to plus L by 2 integration. That's it. After that, I'll send a worksheet to you. So mug up the standard list of formulas for moment of inertia of a ring disk like that. It will be there. If you can mug up, it's good.